Hey, hello, welcome back to our channel. Now we are going to discuss about part 2 of the electric charges and fields. In part 1 we discussed about the Coulomb's law and applications of the Coulomb's law, and we concentrated on the electric force and applications of the electric force. Now we are going to discuss about our main topic in this is the electric field. First of all, what is the electric field? See, suppose you are placing one magnet. It modifies the space surrounding it. So when you are placing any one magnet also, it may be attracting or it may be repelled based on the poles. So like that in electricity also, when you are placing the charge in this space, it modifies the space around it. That is called the electric field. How we are showing here? So electric field is the space around the charge where it shows its effect. This is called the electric field. Then we are going to discuss about intensity of electric field. Intensity of electric field is represented by E bar. E bar means it is a vector quantity. In this case, what happens? This intensity is different at different positions. Suppose we are placing another charge here, somewhat more distance, less effect is there. When we are bringing towards that, somewhat more effect. That is called the intensity of electric field. What is the basic formula for intensity of electric field? It is the force per unit charge. It is the force per unit charge is called the intensity of electric field. In terms of magnitude, simply you can say that E bar equals to F bar by Q also. One simple problem I want to share with you. Suppose if F equals to 100 newtons, then Q equals to 2 coulombs. Then intensity is how much? 100 by 2 is the 50 Newton per coulomb. This is the unit for intensity of electric field. And in this case, one more formula is there. From the Coulomb's law, you know that force formula. E equals to, instead of F, we are writing 1 by 4 pi epsilon naught Q square by R square divided by Q. After simplification, we are getting the expression for intensity, that is E equals to 1 by 4 pi epsilon naught Q by R. Many people are confusing force and intensity. In this force, you are getting Q1, Q2, but here intensity only one charge is there, that is Q by R square. This is the expression for intensity. So don't stick for only one formula. It is in terms of when they are giving force and charge. This is the formula to find out the intensity of the electric field. When you know the charge and distance, this is the formula to find out the intensity of electric field. In terms of vector notation, how to express this one? Look here. E equals to, we can write it 1 by 4 pi epsilon naught Q by R cube along the direction of R bar. Like that, we can show in terms of unit vector also. 1 by 4 pi epsilon naught Q by R square, then R cap. So this is also one of the formula in terms of the vector notation. Don't confuse here. Then we are going to discuss about what is the direction of intensity of electric field. Suppose we are taking positive charge, it is acting away from this. If you are taking negative charge, it is towards the negative charge. This is the direction of the intensity of electric field. Suppose we are taking two charges, one is the Q1, another one is the Q2. Where the intensity becomes to 0, the total distance is R. Suppose you feel this is the X distance, means this is R minus X. Same like force also. Here you can find out X equals to R by under root Q2 by Q1 plus R minus 1. So this is about the null point in the case of intensity of electric field. Then we are going to discuss about electric lines of force. What are the electric lines of force? It is an imaginary line. See, we are taking one is the positive charge, one is the negative charge. Now we are placing one unit positive test charge here. It is repelled by the positive charge and it is attracted by the negative charge. So it is an imaginary path, an isolated unit positive test charge. So these are the electric lines of force. These are diverging from positive charge and converging at negative charge. So these are traveling from positive to negative. So these are diverging here and these are converging here. And no two electric lines of force not intersect. If they are intersecting means, look here clearly. My finger is showing one direction, marker is showing another direction. Is there any possibility for anything two directions? No. So it is impossible. That's why there is no two electric lines of force are not intersect. Then second one, tangent on this at any point. This is the direction of intensity of electric field. What is the direction of intensity means? Tangent on the electric lines of force, it is giving the intensity. If more number of electric lines of force, more intensity is there. So this is about the electric lines of force. Then we are going to discuss about what is the intensity of electric field in uniform electric field. Suppose we are taking one uniform electric field. Uniform electric field means intensity is same both in magnitude and direction. That is called the uniform electric field. You are placing, this is the uniform electric field. This intensity is E. We are placing one charge Q. Suppose it is in equilibrium. It is in equilibrium. Meaning is the word F equals to EQ. One more formula we got for force. E equals to F by Q means F equals to how much? EQ. But here F equals to EQ from the Newton's second law. Force we can take it mass into acceleration. So in terms of intensity and charge, what is the formula for acceleration of that one in that uniform magnetic field? A equals to EQ by M. Suppose here initial velocity equals to 0 and acceleration is EQ by M. This is we can apply for equations of motion also. V equals to U plus AT. Then S equals to UT plus half AT square. Sn equals to U plus A by 2 into 2n minus 1. So all these, wherever the acceleration, here also the charge is moving in uniform magnetic field. Suppose it is moving up means we can able to find out final velocity, displacement, acceleration, whatever it is. Already acceleration we can able to find like this. Then final velocity is, initial velocity is 0 means EQ by M into T. Instead of acceleration, V equals to U plus AT. S equals to half into, instead of A, VQ by M into T square. Then V square minus 0 square equals to 2 into EQ by M into S. So with the help of this, we can able to find out final velocity, displacement and final velocity of that charged particle in the uniform electric field. Then we are going to discuss about another condition also, like we are taking the charges like this. We pulled one side. Okay, here tension, and this tension is resolved into two components. How much force we are applying here? F. Here F equals to EQ. And in this case, weight is, you know, that resolved into two components. This is mg. This is mg cos theta. It is theta. And this is mg sin theta. If the charge is in equilibrium, tension is balanced by mg cos theta. This force EQ equals to what we are writing? Mg sin theta. So with the help of this, we can able to find out the tension and everything here. Like that, when the body is, when the charged particle is projecting in the uniform electric field, it is having which path? Parabolic path. So this is the uniform electric field. This is the uniform electric field of intensity is how much? E bar. Here charged particle is projecting. In this case, same like this. Here ux equals to u. Initial uy equals to 0. Horizontal velocity is not changing, but vertical velocity is uy equals to a into t. Instead of a, we are taking eq by m into t. As usual, we are getting the parabolic path after simplification. So we can able to apply the equations of motion, this one also. Then we do one problem also. Suppose if intensity equals to 10 Newton per coulomb. Mass of the body is like a 0.1 grams. Okay. So this is the mass. Charge equals to 2 coulombs. 2 2 coulombs. Then how to find out the acceleration of this one? Acceleration, what is the formula? EQ by m. So don't think I want mass, I want acceleration and all this. Whenever acceleration means that is there in linear mechanics, but here also in terms of charge also we can able to find out the acceleration. So here acceleration equals to E value how much? 10. This is 0.1 grams means 10 power minus 4 kgs converted into kgs. And mass of this one is, EQ. Here Q is the 2 and this is 10 power minus 4. After simplification, 2 into 10 to the power of 5 meter per second square. So this is the acceleration of the charged particle. This is belongs to intensity. Now we are focusing on electric dipole. What is the electric dipole? We are taking equal and opposite charges. Magnitude is same, but we are taking two opposite charges and placing at definite distance. That arrangement or that system is called the electric dipole. Look here. Electric dipole arrangement is like this. One is the positive charge Q, another one is the negative charge Q. Same magnitude. If it is 2 coulomb means this is also 2 coulombs. Both are separated by a distance 2a. This arrangement is called what? Electric dipole. 2 poles it is having. How we are expressing this nature, and this one is called the electric dipole moment. It's very important. Electric dipole moment. This is the vector quantity. It is the product of one of the charge into distance between these two. Its direction is from negative charge to positive charge. Very important this point also. Negative charge to positive charge. Suppose if 2a equals to 2 centimeters and q equals to 4 coulombs. What is the dipole moment? Just you should multiply these two. So 8 into centimeters we should convert into meters. 8 into 10 power minus 2. But what is the unit for this? Unit is the coulomb meter. Not cm, coulomb meter is the unit for electric dipole moment. Now we are going to discuss about different cases. What is the intensity of electric field on the axial line, on equatorial plane, or at any angle also we can able to find out. These are very important for IPE also. I think you were perfect in that. See, intensity of electric dipole on axial line. What is the formula? Actually, what is axial line? This is negative charge, this is positive charge. The line which is passing through the two charges is called the axial line. Here what is the intensity means? E equals to 1 by 4 pi epsilon naught 2 pi r by r square minus L square whole square. So like this. If r is very greater than L, r square minus L square, approximately we can take it r square only. Then intensity is how much? 1 by 4 pi epsilon naught. Here 2 pi r by r square whole square is the r to the power of 4. After simplification, E equals to 1 by 4 pi epsilon naught 2 p by r cube. They will mention in your problem. Short electric dipole means directly you can go through the 2 p by r cube. Suppose they are giving the distance. This is the r, center to here. And this is the distance between these two is how much? 2 here. So like this we have to do that. One problem also we are doing. Find E if P equals to 3 coulomb meter, R equals to 2 meters for short dipole. So E equals to, how to find out this value? We know that 9 into 10 to the power of 9, 2 into 3 by, this is how much? R cube. R cube we are taking how much? 8. 2 4 27 by 4. 6.75 into 10 to the power of 9 Newton per coulomb. Like that we should calculate the intensity of electric field on the axial line. Like that, how to find out the intensity of electric field on the equatorial line? On the equatorial line also I want to give you direct formula. First of all, what is the equatorial line? See, intensity of electric field on equatorial plane. The line which is passing perpendicular bisector or perpendicular to this length, this is called the equatorial line. You know the direction of the intensity is away from the positive charge and towards the negative charge. And this is diagonal is representing the intensity of electric field on the equatorial plane. So after simplification, this length is how much? 2l. This distance is r. It is under root l square plus r square. E equals to 1 by 4 pi epsilon naught p by r square plus l square whole to the power of 3 by 2. Here p already you know that 2lq or 2aq also we are taking. This is the electric dipole moment. Suppose if r is very greater than l, what we are taking? We can go through the E equals to 1 by 4 pi epsilon naught p by, neglect this l square, r square whole to the power of 3 by 2. 2 cancel, you can get it. E equals to 1 by 4 pi epsilon naught p by r cube we are getting. P by r cube. Then next thing is we do one problem here also. If P equals to 4 coulomb meter and R equals to 3 centimeters. Find the intensity due to equatorial plane, means 9 into 10 power 9. P value how much? 4. R cube means 27 into centimeter cube means 10 to the power of minus 6. After simplification, answer is how much? 4 by 3 into 10 to the power of 15 Newton per coulomb. Otherwise, it should be right 1.33 into 10 to the power of 15 also. So, like that, depends on the condition. First, you read that question, is it axial line or equatorial plane? Suppose at any angle also we can able to find out. How to find out that one? One common formula is there for that intensity. That formula is intensity at particular angle. Intensity of electric field at any angle. So you can take it E equals to 1 by 4 pi epsilon naught p by r cube under root 1 plus 3 cos square theta. 1 plus 3 cos square theta. See, for axial line, theta is how much? 0 degrees. Cos 0 equals to 1. 1 plus 3 is the 4. Under root 4 is the 2p r cube. 2p by r cube. For equatorial line, theta equals to 90 degrees. Cos 90 is 1. Under root 1 is the 1. Same like that. Suppose if theta equals to 45 degrees. How to find out the intensity? 1 by 4 pi epsilon naught p by r cube under root 1 plus cos 45 is the 1 by root 2 whole square is the 1 plus 3 by 2. After simplification, suppose here p equals to 2 and r equals to 1 meter. Then 9 into 10 to the power of 9 divided by r cube is the 1 and p is the 2 into under root, this is how much? Under root 5 by under root 2. Like that we have to do the calculations. So this is the intensity of equatorial plane, axial line or at any angle also we can able to find out with the help of this concept. Then we are going to discuss about this belongs to intensity. Couple acting on electric dipole placed in uniform electric field. That is also you are having one of the short answer. Couple acting on electric dipole placed in uniform electric field. See, we are taking one uniform electric field. We are taking one dipole One is the positive charge, another one is the negative charge. Here torque tau equals to, we are getting PE sin theta. Tau maximum equals to how much? PE when theta equals to 90 degrees. Like that, tau minimum equals to how much? That is the 0 when theta equals to 0. One problem also we are doing. If tau equals to half of the, suppose we are taking tau equals to P, then theta equals to 90 degrees anyway. Suppose find tau, if P equals to 4 coulomb meter, E equals to 10 Newton per coulomb, and theta equals to 30 degrees. How to find out the tau in this case? See, PE 40 by sin 30 is the 1 by 2. So 20 Newton meter. Like that we have to find out. Another question also we are doing here. If tau equals to half of the maximum of torque. Half of the maximum, we know that how much it is PE. Half of the maximum means PE by 2. Find theta. How to find out? So tau equals to, we know that PE by sin theta. Clearly they have given tau equals to PE by 2 equals to PE sin theta. Here this PE cancel. 1 by 2 we are writing sin 30 degrees equals to sin theta. Sin cancel. We are getting theta equals to 30 degrees. So the whole equations belongs to intensity of electric field, and one more is there, that is the part 3. Later we are part 3 also I will make it. Thank you everyone. Please subscribe my channel.